Good afternoon, everyone. We will go through this last topic of the Fourier series, that is Parseval's identity. So Parseval's identity, normally it is asked in the deduction part. You will be asked to find the Fourier series for the functions, hence use Parseval or hence deduce that, or by using Parseval's identity deduce that. So normally it is asked in the deduction part. Okay, Parseval's identity is normally asked in the deduction part, but sometimes they can ask you as a 8 marks question or 6 marks question also, but normally it is a 2 marks part, the deduction part. Okay, so what is a Parseval's identity? Okay, so what is the Fourier series of length 2 pi we have done? Fourier series of length 2 pi means there are two intervals in this, 0 to 2 pi and minus pi to plus pi. When I say Fourier series of length 2 pi, the meaning is the length of the interval may be from 0 to 2 pi or maybe from minus pi to plus pi. Okay, there are two types. So in both the cases, we write the function f of x to be equal to a0 by 2 plus summation n varying from 1 to infinity a n cos nx plus b n sin nx. This we've already done. How to write the Fourier series for a function defined in 0 to 2 pi or minus pi to plus pi, or we can say defined in a Fourier series of length 2 pi. Okay? This we have already done it. So now Parseval's identity, the proof is not there in the syllabus. So I'll just show you the identity part. Okay, the proof part, actually how we get is, we multiply this whole series by f of x and integrate on both the sides. Okay, normally we get the Parseval's identity by multiplying both the sides by f of x and integrating between the limits given in the problem. So I will not show you the proof of that part. So what happens is when you multiply by f of x and then take the integration, it reduces to this form. Since the function is defined in 0 to 2 pi, we will have integral 0 to 2 pi. Since I'm multiplying by fx the whole equation, we will get f of x the whole square. So suppose you multiply this by fx and then take the integration 0 to 2 pi. So what is integration 0 to 2 pi f of x dx in terms of a0? What is integration of 0 to 2 pi f of x dx in terms of a0? Normally, how do we write a0? It is 1 by pi integral 0 to pi f of x dx. So I can write integral f of x dx is equal to a0 pi. So that way, if you write each one, we will get it as a0 squared by 2 plus summation an squared plus bn squared. Okay. So how I'm getting this Parseval's identity? You are multiplying throughout by f of x and taking the integration from 0 to 2 pi. So here you will get integration of f of x dx, which is again pi into a0. Here it will be integration of f of x into cos nx, that is an into pi. Then integration of f of x sin nx is bn into pi. So again you will get that pi is taken over here. We will get 1 by pi integral 0 to pi f of x the whole square dx is equal to. So when we have Parseval's identity, everything is taken square. If it's a0 by 2, we write it as a0 square by 2. If it is an cos nx, only the coefficients are taken into account here. So an square, यहाँ पे bn square. Then this is multiplied by f of x, so we will get f of x the whole square. ठीक है? तो याद कैसे रखना है? अगर पाई वाला इंटरवल है तो पहले सबका स्क्वायर लिख दो, f of x the whole square, a0 square, an square, bn square, and then left hand side whatever is the integral limits given 0 to 2 pi, and 0 to 2 pi का normally 1 upon pi रहता है, a0 an और bn. So I will take it as 1 upon pi. इसके मतलब when we write a0 an and bn, the term which is outside the integration is 1 by pi. वही term यहाँ पे आ जाता है. Okay, so to remember this, whatever is the series, f of x को square करना है, a0 को square करना है, an square and bn square. Integration खाली left hand side में आएगा. जो भी limits दिया है, that has to be substituted over here. And normally in the formula for a0, an and bn, we get 1 by pi. That 1 by pi comes over here. एक्चुअली हमें करना क्या है, इसको पूरे एफ ऑफ एक्स से मल्टीप्लाई करना है और इंटीग्रेट करना है, एंड सो वी विल गेट द पार्सिवल्स आइडेंटिटी इन 0 to 2 पाई। अगर वो माइनस पाई टू प्लस पाई दिया है तो सेम फंक्शन, खाली द लिमिट्स आर चेंज, माइनस पाई टू प्लस पाई। ओके, so you may be asked some question, find the Fourier series in 0 to 2 pi, and then hence use Parseval or hence deduce using Parseval's identity. So that means you have to calculate the Fourier series in 0 to 2 pi, calculate a0, an and bn, and then substitute in these Parseval's identity to get the required deduction. ठीक है, तो हर एक टर्म को स्क्वायर कर, जस्ट राइट द फोरियर सीरीज, यू ऑलरेडी नो हाउ टू राइट द फोरियर सीरीज और ए हाफ रेंज सीरीज। सो राइट द फोरियर सीरीज, जो भी इंटरवल दिया है दैट विल बिकम द लिमिट्स ऑफ इंटीग्रेशन, और हर एक टर्म को स्क्वायर करना है, एफ ऑफ एक्स को स्क्वायर, ए जीरो को स्क्वायर, ए एन स्क्वायर एंड बी एन स्क्वायर, देयर आर नो कॉज और साइन इन द पार्सिवल्स आइडेंटिटी। ठीक है, सिमिलरली when we want to write the Fourier series of length 2l, which means there are two intervals 0 to 2l or minus l to plus l, तो हम नॉर्मली ऐसा लिखते हैं, f of x is equal to a0 by 2 plus summation n varying from 1 to infinity an cos n pi x by l plus bn sin n pi x by l. This is the Fourier series in the interval either 0 to 2l or minus l to plus l. ठीक है, तो ये सेम सीरीज में फिर से हमको वही लिखना है, पार्सिवल्स आइडेंटिटी। Normally, when we calculate a0, an, and bn for the length of interval 2l, we write 1 by l outside. 1 by l integral f of x dx. 1 by l integral f of x into cos. 1 by everywhere we have 1 by l. तो यहाँ पे भी the left hand side will be 1 by l. जो भी interval दिया है that will be the lower limit and the upper limit, और फिर सबका square. f of x square, a0 square, an square and bn square. ठीक है, वैसे ही अगर माइनस एल टू प्लस एल दिया है तो सेम फॉर्म, खाली द लिमिट्स ऑफ इंटीग्रेशंस आर चेंजिंग हियर फ्रॉम माइनस एल टू प्लस एल। Okay, so these are the four types of same Parseval's identity, but I've shown in different intervals because we have Fourier series in 4 intervals. So I've shown you all the Parseval's identity also in these 4 intervals. Right hand side तो same है, खाली लेफ्ट हैंड साइड में चेंज आता है, अगर एल का इंटरवल है तो 1 बाय एल आता है, और अगर पाई का है तो 1 अपॉन पाई आता है, और यहाँ पे जो भी इंटरवल दिया है दैट विल बिकम द लिमिट्स ऑफ दीज इंटीग्रेशंस। अगर 0 to 2 पाई दिया है तो 0 to 2 पाई, फिर यहाँ पे पाई आ जाएगा। 0 to 2l है तो 0 to 2l, यहाँ पे l आ जाएगा। सिमिलरली अगर माइनस एल टू प्लस एल दिया है तो माइनस एल टू प्लस एल एज द लिमिट्स ऑफ इंटीग्रेशन, and L is the 1 by L is the term which is outside. Okay, अगर हमें ना हाफ रेंज सीरीज लिखना है, सपोज हमें लिखना है हाफ रेंज कोसाइन सीरीज, ठीक है, तो क्या चेंज आएगा यहाँ पे? हाफ रेंज कोसाइन सीरीज अगर मुझे लिखना है, द लेंथ ऑफ द इंटरवल विल बी L हियर, तो क्या चेंजेस आएंगे यहाँ पे, क्या फर्क रहेगा इसमें और द Parseval's identity in half range series? Can you say what should be the difference here? अगर कोसाइन पूछा है तो bn का पार्ट तो 0 हो जाएगा, और अगर साइन पूछा है तो a0 an का पार्ट 0 हो जाएगा। ओके, दैट पार्ट इज ओके। व्हाट विल हैपन टू दिस टर्म आउटसाइड? यहाँ पे 1 by l है, वहां पे क्या होगा? 2 by l, करेक्ट। It is going to be 2 by l because हम जब a0, an और जो भी निकालते हैं हाफ रेंज सीरीज में या इवन और ऑड फंक्शन में, या इट इज 2 by l ओनली, तो यहाँ पे भी हमको 2 by l करना है और कुछ नहीं करना है। तो सेम वे हाफ रेंज सीरीज, हाफ रेंज कोसाइन सीरीज में अगर पार्सिवल्स आइडेंटिटी लिखना है तो पाई वाला इंटरवल है तो 2 by पाई, और अगर साइन रहेगा तो bn स्क्वायर। और कोसाइन में खाली a0 और an आता है, साइन में खाली bn आता है, the left hand side part is the same. मतलब अगर इवन फंक्शन है, ऑड फंक्शन है, तो we can write as 2 by l. Even when we write 1 by l integral minus l to plus l, अगर वो इवन फंक्शन है तो it is automatically 2 by l only. सेम फॉर्मूला है, खाली हमें यही पार्ट अलग है, बाकी तो सब सेम है। Only this part outside the integration part and the limits of integration. लिमिट्स ऑफ इंटीग्रेशन आर सेम एज द इंटरवल गिवन. खाली ये वाला पार्ट अलग है, बाकी सबका सेम सीरीज है. Similarly, we can have for the cosine series in 0 to L. 2 by L हो जाएगा. Now 2 by L will come when we have the L interval, and when we have pi interval, 2 by pi will come. ठीक है. So cosine series में we treat the function as an even function. So Bn part is 0. And when we write the half range sine series, A0 and An are 0, we treat this function as an odd function and calculate only Bn. ठीक है. So in most of the, almost 99% problems will be asked in the deduction part only. Very few problems are there where I don't think they will ask the whole problem as such, but still I'll just show you one problem based on that also how they can ask. Okay? Hope you have written all the Parseval's identity in each of the intervals. So first problem, find the half range cosine series for f of x is equal to x 0 less than x less than 2 using Parseval's identity. Deduce that. Okay, normally this is the question, this way the questions are asked. Find the half range or find the Fourier series, and then using Parseval's identity deduce that. और अगर ये नहीं दिया है, Parseval's identity प्रॉब्लम में नहीं दिया है, still we have to prove some deduction. तो आइडेंटिफाई कैसे करना है कि अगर तुम्हारे an में 1/n square है, सपोज when we calculate for cosine series, if we calculate an, suppose an is 1 by n square something, and you are asked to calculate n raised to 4 like, then we have to make use of Parseval's identity. If it is not specified in the problem, तो अगर an में n square है और यहाँ पे पूछा है 1 raised to 4, 2 raised to 4 etc., then we have to make use of the Parseval's. अगर जो भी an और bn आया उसका अगर स्क्वायर का टर्म पूछा है डिडक्शन में, तो अप्लाई द Parseval's identity. Okay. Am I audible now? Yes, okay. There was some network issue. I don't know. Suddenly it got logged off. Okay. Yeah. So tell me, what is the length or what is L in this problem? Half range cosine series for f of x is equal to x. What is the value of L? Okay, L is equal to 2. So normally, if you take a Fourier series, the length of the interval is either 2L or 2 pi. In the half range series, the length of the interval is L or pi. So here it is a half range series defined in 0 to L. So L value is equal to 2. So now calculate half range cosine series. तो क्या निकालना है? A0 और AN निकालना है. So calculating A0 and AN. So use the formula. पहले हमको जो हम लोग ने किया अभी तक वही करना है. उसके बाद we have to apply the Parseval's identity. So calculate A0. A0 का फॉर्मूला होता है फॉर एन इवन फंक्शन 2/L इंटीग्रल 0 to L fx dx. F of x is given as x and L is equal to 2 here. So 2/2, that will become 1, integral 0 to 1, f of x is x dx. What is the value of A0? What is the value of A0? Integrating x between the limit 0 and 2, what will be the answer for A0? Two. Okay, A0 is 2. So x square by 2 between the limit 0 and 2. So we will get 2 square by 2, which is equal to 2. So A0 is equal to 2. Okay, A0 by 2 is equal to 1. Fine. AN. Calculating AN. AN is 2/L integral 0 to L fx cos n pi x by L. Substitute for fx and L. L is 2, f of x is x. Use u into v. So write first bracket as u, second bracket as integral v. Go on differentiating the u function, integrating the integral v function. पहले x को लिखना है. I'm repeating again and again. What is u into v? The generalized rule. First it write x, then the integration of cos is sine, minus derivative of x is 1, integration of sine is minus cos. So what is the value for this? When I apply x equal to 2, first term will become 0 because यहाँ पे हो जाएगा n pi 2/2. This 2 will get cancelled, खाली sin n pi बचेगा. तो sin n pi is equal to 0. Lower limit में भी sin 0 0 हो जाएगा. So we will have only the second term. So when we apply the upper limit, यहाँ पे आ जाएगा 2/2 will get cancelled. Cos n pi. Okay. Here the answer will be cos n pi. Denominator we are having n pi by 2 the whole square. इसका अगर bracket open किया तो we will get 4/n square pi square. Lower limit में जब x को 0 put किया तो ये 1 हो जाएगा तो 4/. This is already a positive sign. So first term positive and this minus sign is for the lower limit. If we can take 4/n square pi square common, we can write as minus 1 raised to n minus 1. Cos n pi is minus 1 raised to n. So AN is 4 into minus 1 raised to n minus 1 upon n square pi square. If there are any mistakes, please tell me, okay? Suppose there is sign mistake or something like that, please let me know. I think it's okay here, no? Minus into minus is plus, so first term positive, lower limit negative sign, 4/n square pi square. So 4 into minus 1 raised to n minus 1 upon n square pi square. Substituting everything in the f of x function, putting a0 as 2 and an as 4 into minus 1 raised to n minus 1 upon n square pi square. Substituting, L is also equal to 2. So f of x will become a0 by 2 will become 1. Then an is 4. Is this true for all the values of n? You have to always check after calculating an or bn. You have to check whether is this value of an, whatever we have got, is true for all the values of n. It is true here because it's becoming infinity only for n equal to 0. लेकिन n equal to 0 हमारे सीरीज में आता ही नहीं है, so we need not bother about that. This is true for all the values of n from 1 to infinity. So we have got f of x is equal to this and 1 plus cos. Now we have to apply the Parseval's identity. Okay? Now we have to apply Parseval's identity. तो यहाँ पे क्या पूछा है, पहले हमको Parseval's identity कोसाइन सीरीज में लिखना है, हाफ रेंज कोसाइन सीरीज. तो बाहर क्या आएगा, 2 upon L integral 0 to L f of x the whole square. Okay, that is the Parseval's identity. We had 2 by L, in हाफ रेंज में है तो 2 by L. Fourier series है तो 1 upon n or 1 upon pi. So it's half range cosine series 2 by n integral 0 to n f of x the whole square is a naught square by 2 plus summation a n square, n is varying from 1 to infinity. Substitute all these values. Okay, L के बदले 2, f of x के बदले x, a0 is 2 and an is equal to 4 into that function in the Parseval's identity. Substitute क्योंकि f of x हमें पता है, a0 we have calculated, an also we have calculated, L is also given. So substituting everything in this Parseval's identity, तो क्या आएगा, 2 by 2, L के बदले 2, 0 to 2, f of x is equal to x, so x square dx, a naught square, a naught is 2, a naught square will become 4, प्लस समेशन ए एन स्क्वायर. तो ये जो पूरे टर्म का स्क्वायर, ओके, whatever we have got a0 an substituting in the Parseval's identity. So since it is a half range cosine series, bn term will not be there. तो खाली a0 रहेगा, an रहेगा, सबका स्क्वायर होगा. लेफ्ट हैंड साइड में f of x का स्क्वायर है and whatever is the interval given, that will be the limits of integration, and since it is half range, you will get 2 by L outside. ठीक है, अभी हमें इसको इंटीग्रेट करना है. सो व्हाट विल बी 2 by 2 विल बिकम 1 x स्क्वायर का इंटीग्रेशन एंड अप्लाई द अपर लिमिट एंड द लोअर लिमिट. तो लेफ्ट हैंड साइड में क्या बचेगा, खाली लेफ्ट हैंड साइड में फंक्शन को इंटीग्रेट करना है, राइट हैंड साइड में खाली कांस्टेंट टर्म्स है. वी आर हैविंग n pi etc. So simplify the left hand side and tell me what is the value of that integral. What is the value we get on the left hand side? क्या आएगा लेफ्ट हैंड साइड में? It is x cubed by 3 between the limits. Yes, it's 8 by 3, correct. 8 by 3 because x cubed by 3 है, between the limits 0 and 2, तो वो हो जाएगा 8 by 3. Okay, तो इसको पहले इंटीग्रेशन किया तो we'll get 8 by 3. 2 square by 2 हो जाएगा 2 प्लस, अभी हमें क्या करना है, n को 1 से इंफिनिटी तक पुट करना है. So we will take out the terms which are independent of n. जो बिना n वाले टर्म से उसको हम बाहर ले लेंगे. तो पहला टर्म है 4, 4 स्क्वायर के अंदर है, तो 4 स्क्वायर मतलब 16 बाहर आ जाएगा. यहाँ पे पाई स्क्वायर, तो होल स्क्वायर विल बिकम पाई रेज टू 4. बाकी टर्म्स को मैंने स्क्वायर के अंदर ही रखा है. ठीक है, because we have to give the values of n from 1 to infinity, the terms which are independent of n are taken outside. So 4 square is 16, pi square is pi raised to 4, then we'll get minus 1 raised to n minus 1 upon n square the whole square. Okay, so left hand side is again 8 by 3 is equal to 2 plus this. अभी हमें क्या निकालना है, 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4. Okay, how did we get this term? Now put n is equal to 1. When I put n is equal to 1, denominator we will have 1 square. यहाँ पे क्या हो जाएगा, -1 raised to 1 minus 1. तो कितना हो गया, -1 minus 1, that will become -2. -2 the whole square will become 4. ये कब है, जब n की वैल्यू 1 है. जब n की वैल्यू 1 है तो यहाँ पे हो जाता है -1 minus 1 which is -2 whole square, that is 4 upon 1 square. और 1 raised to 4 है कैसे, बिकॉज अगर इसको स्क्वायर को सेपरेट किया तो n raised to 4 हो जाएगा. पुट n is equal to 2. अगर n को 2 पुट किया तो -1 the whole square हो जाएगा 1. 1 minus 1 will become 0. So when n is an even term, we will get the whole term to become 0. इसीलिए यहाँ पे खाली odd terms है. Again जब n को 3 पुट किया तो we will get -1 minus 1, that is again -2 the whole square, which is again 4. So 4 upon 3 raised to 4. So when we put n is equal to the even terms, the values are 0 because -1 raised to n minus 1 is equal to 0 when n is even. तो हमारा आता है 4 upon 1 raised to 4, 4 upon 3 raised to 4, and 4 upon 5. Clear this part? How did we get this series? We are substituting n is equal to 1, 2, 3, etc. When we put 1, 2, 3, etc. and when I put n is equal to 2, 4, this whole terms become 0. इसीलिए यहाँ पे 2, 4 के terms नहीं आ रहे हैं. Now take out everything, keep only the series term on one side and all the other constants to the other side, and calculate what is 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4. So if we take 2 on the left hand side, pi 8 by 3 minus 2 is 64. 4 can be taken common, so 64 upon pi raised to 4. Now 8 by 3 minus 2 is 2 by 3 because 8 minus 6 by 3 will become 2 by 3. Cross multiply, pi raised to 4 upon 96 will be equal to 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus 1 upon 5 raised to 4. This is the first part which was to be proved. Using Parseval's identity, show this result. Pi raised to 4 by 96 is equal to 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus etc. Any doubt in this? कुछ नहीं कर रहे हम लोग, जो हम लोग निकाल रहे थे अभी तक, आइदर फोरियर सीरीज निकालना है या हाफ रेंज निकालना है, और उसमें हमको n is सब्स्टिट्यूट करना है पार्सीवल्स में, and then put n is equal to 1, 2, 3, etc. and see what is the series we get. That is only we have to do it in Parseval's identity. हर एक टर्म को स्क्वायर लिखना है, उसके बाद उसको सिंप्लीफाई करना है. There are two parts, two deduction part asked. So one is this. The second part which was asked is, ये proof करना है. Pi raised to 4 upon 90 is equal to 1 upon 1 raised to 4, 1 upon 2 raised to 4 plus 1 upon 3 raised to 4. The second part which is to be proved. तो लास्ट स्टेप में क्या था, पाई रेज टू 4 by 96 is equal to 1 upon 1 raised to 4, 1 upon 3 raised to 4 and 1 upon 5 raised to 4. मतलब जो ऑड का जो raised to 4 था, that is given as pi raised to 4 by 96. Now what we have to show is 1 upon 1 raised to 4 plus 1 upon 2 raised to 4, all the term, that is equal to pi raised to 4 by 90. So what we will do is, we will assume that let S to be equal to this term. Whatever we have to prove the series, let S be equal to the right hand side of the prove that series. So let S be equal to 1 upon 1 raised to 4, 1 upon 2 raised to 4 and 1 upon 3 raised to 4 plus etc. Now, we know what is 1 upon 1 raised to 4 plus 1 upon 3 raised to 4 plus etc. from the previous. So what we will do is, we will combine the odd terms together and the even terms together. So we will combine the odd terms and even terms, because here we have all the numbers 1, 2, 3, 4. तो जितने भी odd वाले terms हैं उसको एक bracket में लिखेंगे and जितने भी even वाले हैं उसको second bracket में. Now this we have already calculated using Parseval's identity. It is equal to pi raised to 4 by 96 in the previous step. ठीक है, हम क्या कर रहे हैं, जो भी राइट हैंड साइड था उसको हमने S लिया है. S में सब टर्म्स है 1, 2, 3, 4 ऑल द टर्म्स आर देयर. अभी हम इसको क्या कर रहे हैं, पहले ऑड टर्म्स को साथ में लिख रहे हैं एंड द इवन टर्म्स आर रिटन टुगेदर. देन ये हमने ऑलरेडी निकाला हुआ है प्रीवियस स्टेप में. सो वी गॉट पाई रेज टू 4 by 96 प्लस 1 अपॉन 2 रेज टू. ओके, नाउ यहाँ पे 1 अपॉन 2 रेज टू 4 कॉमन है. सो वी कैन टेक 1 अपॉन 2 रेज टू 4 कॉमन. तो क्या बचेगा, यहाँ पे हो जाएगा 1 अपॉन 1 रेज टू 4 प्लस ये कितना बचेगा, इज इट 2 रेज टू 4. 4 रेज टू 4 में से अगर 2 रेज टू 4 बाहर निकाला तो क्या बचता है, इज इट 2 रेज टू 4. Is it okay? Second term, 1 upon 2 raised to 4 plus 1 upon 3 raised to 4. Yes? Okay. So we are taking 1 upon 2 raised to 4 common. ठीक है, तो ये क्या हो गया ब्रैकेट टर्म. अगेन इट कैन बी रिप्लेस्ड बाय S. अगर मैंने 1 upon 2 raised to 4 यहां से बाहर निकाला तो हमारा फिर से S का टर्म आ जाता है. So we can write pi raised to 4 by 96 plus 1 upon 2 raised to 4 into S. Now bring all the S terms to one side and calculate what is S from there. So 2 raised to 4 is 16. So we will get S is equal to. So what we are doing is taking the right hand side as S and then splitting this right hand side part as some of the odd terms and some of the even terms. Odd terms already we have the answer. Even terms में से हम लोग जो common है 1 upon 2 raised to 4 that is taken common. So once we take 1 upon 2 raised to 4 common, the remaining part is same as your S function. तो यहाँ पे 1 upon 2 raised to 4 S हो जाता है. Now 2 raised to 4 is 16. So we can write S is equal to pi raised to 4 by 96 plus S by 16. Now bring this S to the left hand side. So S minus S by 16 is pi raised to 4 by 96 or 15 S by 16 is pi raised to 4 by 96 or S is equal to pi raised to 4 by 90. S is equal to pi raised to 4 by 90. Is it okay? 16 by 15 into 96, is it 90? Yes, okay. Okay. But S is equal to 1 upon 1 raised to 4 plus 1 upon 2 raised to 4, etc. So we can write the series to be equal to pi raised to 4 by 90. Next one. half range sine series for f of x is equal to x into pi minus x, 0 less than x less than pi. Using Parseval's identity, deduce that pi raised to 6 by 960 is equal to 1 upon 1 raised to 6 plus 1 upon 3 raised to 6 plus 1 upon 5 raised to 6 plus etc. So we have to calculate half range sine series, which means only Bn is to be calculated. So calculating Bn for this function and then using the Parseval's identity for half range sine series, we have to get this result. तो सबसे पहले हमको Bn निकालना है. The interval given is 0 to pi. मतलब Bn का फॉर्मूला हो जाएगा 2 by pi integral 0 to pi f of x into sin nx dx. Bn is equal to 2 by pi integral 0 to pi fx into sin nx dx. Substitute for f of x and then use uv rule to integrate the function and calculate what is Bn. So Bn, since half range sine series is asked, we have to calculate only Bn as a0 and an will become 0. जो भी फॉर्मूला हम लोगों ने ऑड फंक्शन में यूज किया था, दैट फॉर्मूला विल कम हियर. Bn is equal to, substituting for the function, now here you're having x into pi minus x. So take x inside and treat this whole bracket term as an algebraic function. Okay? Take x inside the bracket of pi minus x and then take that whole function as u and sine function as v. We can write pi x minus x square into sine nx dx. Please show the previous slide. Okay. Done? Okay. Calculating Bn. Use u into v, 2 by pi integral 0 to pi. अभी ये हमारा फंक्शन u हो गया, pi x minus x square is u, sin nx is v. So use u integral v. तो पहले u लिखना है, इंटेग्रल v माइनस पाई एक्स माइनस एक्स स्क्वायर का डेरिवेटिव पाई माइनस 2x, पाई माइनस 2x का डेरिवेटिव -2, माइनस साइन का इंटीग्रेशन माइनस कॉस का माइनस साइन एंड माइनस साइन का फिर से कॉस. We go on integrating the integral v function and differentiating the u function. Apply the upper limit and the lower limit. When we apply the upper limit, when x is pi, we'll get pi square minus pi square. This term 0. Sin n pi is 0. Only this term will remain. So minus 2 cos n pi upon n cube. Again, when x is 0, first term is 0, sin 0 is 0. Again, we will have the third term. So minus 2 cos n pi upon n cube minus of minus 2. This minus sign is for the lower limit. Cos 0 is 1, so 1 upon n cube. We can take 2 common, or n cube, or 2 upon n cube, we can take it as common. Or we can write 4 upon pi n cube. This term is written first. So 1 minus cos n pi. 4 upon pi n cube into 1 minus cos n pi. Cos n pi is minus 1 raised to n. 4 upon pi n cube into 1 minus 1 raised to n. Substitute in the f of x series. Substituting bn. So is it true for all the values of n? After calculating an or bn, we have to always check whether those Fourier coefficients are true for all the values of n. A0 is not having n in it, but an and bn. We have to check whether the values, whatever we have got bn, is this true for all the values of n. So here it is true for all the values of n. We can directly substitute. Substitute करना है यहाँ पे. Now use Parseval's identity to get that required deduction part. Using the Parseval's identity, we have to get the deduction part. We have to prove pi raised to 6 upon 960 is 1 upon 1 raised to 6, 1 upon 3 raised to 6, and 1 upon 5 raised to 6. Now what we have got in bn, bn में n cube आया है और हमें क्या पूछा है 1 raised to 6, 3 raised to 6, 5 raised to 6 पूछा है. यहाँ पे raised to 3 है, यहाँ पे raised to 6 पूछा है. क्या अगर raised to 3 ही पूछा है, then you give the values of x equal to 0 ले लो, pi by 2 या कुछ भी values ले लो. ओके अगर यहाँ पे n क्यूब है आंसर में और यहाँ पे भी क्यूब ही पूछा है तो यू गिव द वैल्यूज ऑफ x. बट इफ यू आर गेटिंग bn में n क्यूब है और यहाँ पे रेज टू 6 पूछा है, विच मीन्स वी हैव टू अप्लाई द पार्सीवल्स आइडेंटिटी. वैसा आइडेंटिफाई करना है कि डिडक्शन पार्ट हमें कैसे प्रूफ करना अगर स्पेसिफाइड नहीं है तो. ओके सो सपोज n क्यूब इज द आंसर वी हैव गॉट इन bn और यहाँ पे भी क्यूब वाले टर्म्स ही हैं तो गिव द वैल्यू ऑफ x. बट हियर इट इज n क्यूब एंड वी हैव टू प्रूव 1 raised to 6, 3 raised to or n raised to 6 is to be calculated, which means we have to apply Parseval's identity. ठीक है, तो Parseval's identity हाफ रेंज साइन सीरीज, तो आउटसाइड द इंटीग्रेशन आ जाएगा 2 by pi इंटीग्रल 0 to pi f of x का स्क्वायर और bn स्क्वायर. f of x is this function, bn is this function. Substituting, integrating on the left hand side and calculating the required series. Substituting for the function f of x. F of x is x into pi minus x, or if I take x inside, pi x minus x square, उसका square लेना है, and then whatever bn we have got, उसका square. So before integrating, use a minus b the whole square. Before integrating, use a minus b the whole square and then integrate. So we will get 0 to pi a square. So pi square x square, 2ab is 2 pi x cube plus b square, which is x raised to 4. Again, the terms which are independent of n are taken outside the summation. नहीं लिया तो भी चलेगा. Okay, we can take it or we need not. It depends upon you. To take, I have taken the terms which are independent of n outside. The 4 square 16 will come out. Pi square will come out. Remaining will be 1 upon n cube, 1 minus 1 raised to n whole square. Integrate with respect to x on the left hand side, apply the upper limit. Just tell me what will be the integration value on the left hand side. लेफ्ट हैंड साइड को इंटीग्रेट करना है, x स्क्वायर का x क्यूब बाय 3, x raised to 4 etc. Apply the upper limit, lower limit. Tell me what will be the answer on the left hand side. So if we integrate, we will get x cubed by 3, 2 pi x raised to 4 by 4, x raised to 5 by 5 between 0 and pi. Pi raised to 5 by 30. Okay. Apply the upper limit as x equal to pi and x equal to 0. तो लोअर लिमिट तो पूरा 0 हो जाए, खाली अपर लिमिट में x को पाई पुट करना है. तो व्हेन आई पुट x इज इक्वल टू पाई, हर एक जगह पाई रेज टू 5 हो जाएगा. So pi square into pi cube, pi raised to 5. Pi into pi raised to 4, again pi raised to 5. Here also pi raised to 5. So we can take pi raised to 5 common. So what we are doing is applying Parseval's identity. fx के बदले जो भी हमको दिया है उसको सब्स्टिट्यूट करना है और उसको स्क्वायर करके इंटीग्रेट करना है. राइट हैंड साइड में bn सब्स्टिट्यूट करना है और जो भी टर्म्स विदाउट n वाले हैं उसको बाहर लेके we have to just simplify those terms. When we apply the upper limit, we will get everywhere pi raised to 5 by 3. The step we will get after applying the upper limit. x के बदले pi, x के बदले 0, x के बदले pi जब पुट किया तो ये वाला टर्म आएगा, x के बदले जब 0 पुट करेंगे तो 0 आ जाएगा. Then simplifying we will get this. Now simplify again, take pi raised to 4 common and simplify, take the LCM etc. If you take pi raised to 5 common, that will get cancelled with this pi, so pi raised to 4 will remain. So we will have 1 by 3 minus 1 by 2 plus 1 by 5. Take the LCM, simplify. तो pi raised to 5 नहीं आएगा हर्ष. 1 pi will get cancelled, I think. Na? Maybe the value of the integration you are telling, I think. Yes, the value of the integration is pi raised to 5 by 30. 2 upon pi is outside. So we will get pi raised to 4 by 15. Then give the values of n now. If we give the values of n, we will get, when n is equal to 1, 1 upon 1 raised to 6. Pi on the other side. तो pi raised to 6 आएगा ना, कैसे कैंसिल करेंगे? अच्छा ये वाला pi. ओके ओके फाइन, ठीक है ओके ओके फाइन. When n is equal to 1, तो ये हो जाएगा 1 minus 1 raised to 1. तो ये हो जाएगा 1 plus 1, that is 2, again square. When n is equal to 2, minus 1 the whole square will become 1. 1 minus 1 will become 0. तो खाली again फिर से odd terms ही बचेंगे. 4 upon 2 square है तो 4 upon 1 raised to 6 plus 4 upon 3 raised to 6 plus 4 upon 5 raised to 6. Take 4 common and simplify. Pi raised to 6 upon 960 is equal to. So we got the required answer, 1 upon 1 raised to 6 plus 1 upon 3 raised to 6 plus 1 upon 5 raised to 6 is equal to pi raised to 6 upon 960. Next type of problem. If pi minus x the whole square by 2 pi minus x by 2 the whole square is equal to pi square by 12 plus summation n varying from 1 to infinity 1 upon n square cos nx in 0 to 2 pi. Find the sum of the series. मतलब यहाँ पे क्या दिया है हमको ऑलरेडी फोरियर या जो भी सीरीज दिया हुआ है. Now, is this a Fourier series or a half range series? जो भी हमको दिया है, is it a Fourier series or a half range series? How do we decide whether it is a Fourier series or a half range series? Fourier series, okay. What about others? Is the given problem a Fourier series or a half range series? Yes, correct, yes. What you are saying is we have to see the interval given. क्योंकि यहाँ पे हमको पता नहीं कौन सा सीरीज दिया है. It may be, it looks like it may be a half range cosine series also. लेकिन how to identify? We have to identify from the interval. क्योंकि फोरियर सीरीज है 0 to 2 pi. हाफ रेंज सीरीज हो तो 0 to pi होता था. ओके, सो विच मीन्स दैट दिस इज अ फोरियर सीरीज. ठीक है, तो अगर फोरियर सीरीज है तो व्हाट इज एफ ऑफ एक्स, व्हाट इज ए जीरो, व्हाट इज ए एन एंड व्हाट इज बी एन फ्रॉम हियर. कैन वी राइट एफ ऑफ एक्स ए जीरो ए एन एंड बी एन. Now f of x is pi minus x by 2 the whole square. A0 by 2 is pi square by 12. And an is equal to 1 upon n square. ठीक है, bn is not given, so bn is equal to 0. Okay, so what we are given a Fourier series in 0 to 2 pi, where f of x is pi minus x by 2 the whole square. A0 by 2 is pi square by 12. And an is 1 upon n square, bn is equal to 0. I'm comparing with the general Fourier series in 0 to 2 pi and writing what is f of x, what is a0, an and bn. Okay, so now we have to write, now how do we know that whether we have to apply Parseval's or any other value for x? हाउ डू वी आइडेंटिफाई वेदर हमें पार्सिवल कब यूज करना है, कैसे यहाँ पे पार्सिवल यूज होगा कि नहीं, कैसे समझेगा. It is not specified that you have to solve by Parseval's identity. So how will we identify whether we have to solve by Parseval's identity or by giving the values of x? उसके लिए हमें क्या देखना है, an is equal to 1 by n square. Yes, here an is equal to n square, 1 upon n square. But in the proof we are having 1 upon n raised to 4 like. Okay, 1 upon 1 raised to 4, 2 raised to 4, 3 raised to 4. लेकिन यहाँ पे क्या है, 1 वेरिंग n is equal to 1 upon n square. n square हमारे पास है and then we have to calculate the square of an or 1 upon n raised to 4. That is why we have to apply the Parseval's identity. So here you need not find the Fourier series. Fourier series is already given to you. We have to find the sum of the series. To find the sum of the series, one way is either you give the value of x equal to something or use Parseval's. Now we can put the value of x equal to something only when we have squared terms in the series. Since we are having raised to 4 terms in the series, we have to use the Parseval's identity. So writing the Parseval's identity in 0 to 2 pi. 1 by pi integral 0 to 2 pi f of x the whole square dx is equal to a0 square by 2 plus summation n varying from 1 to infinity an square plus bn square. All the values we are having now. f of x भी है, a0 भी है, an भी है, bn भी है. Substitute everything and calculate or get the required sum of the series. Substituting for f of x, substituting for a0, an. So when we substitute, f of x is pi minus x by 2 the whole square, a square is pi square by 6 the whole square upon 2 plus summation. Simplify everything, open this bracket, तो यहाँ पे we can take, it is actually whole raised to 4, pi minus x by 2 whole raised to 4. So this 2 raised to 4 will come out, that will become 16 pi, then pi minus x raised to 4, and if you simplify this, pi raised to 4 upon 36 into 2, which is 72, plus summation 1 upon n raised to 4. Now use a minus b whole raised to 4, or can we do it directly also, integration? Do we have to apply a minus b whole raised to 4, or directly also can we integrate? There are two methods. Either you apply a minus b whole raised to 4 or directly a plus bx whole raised to n का integration कर सकते. I have expanded here. It's not required because just now I thought we can do it directly also. It will become pi minus x whole raised to 5 upon minus 5. But I have here expanded that. We know how to expand a minus b whole raised to 4 by using the binomial expansion. We write the coefficients by using the Pascal's triangle. So the coefficients are 1, 4, 6, 4, 1, alternate plus and minus. The first term goes on reducing and the second term keeps increasing. So using this formula, I've expanded a minus b whole raised to 4. It is not required, you can do it directly also. A minus bx whole raised to n का integration होता है a minus bx whole raised to n plus 1 upon n plus 1 into b. Directly भी integrate कर सकते हैं. Actually, I've used here the expansion part, which is not required. So now integrate term by term, apply the upper limit, lower limit. Everywhere I am integrating now. X square by 2, x cube by 3, x raised to 4, x raised to 5 by 5. And then applying the upper limit and the lower limit will become 0. उसमें से हमें summation निकालना है 1 upon n raised to 4 की value. Simplifying the terms on the left hand side. Everywhere you will get again pi raised to 5. Simplifying, we will get pi raised to 4 upon 40 is equal to pi raised to 4 upon 72. Subtract it or take this term to the left hand side and calculate summation of 1 upon n raised to 4. Okay, so are we getting the answer? Pi raised to 4 upon, is it 90 the denominator? I doubt. What was the question? I think it was not 90. So we had to prove this result. Okay. We had to prove that, find the sum of the series. Okay. So normally Parseval's identity is used in deducing some series from the Fourier series or half-range series. Okay, so with this Fourier part is over. We'll start with the next module next week.